Today's objective is equations with two variables. Vocabulary words. Solution, an ordered pair that makes an equation a true statement. Linear equation, an equation whose graph is a line. VIC number 1. Remember that VIC stands for very important concept. You can use two variable equations to model real-world situations. VIC number 2, one way to show solutions to an equation is to graph them. Very important concept. Number 3, a linear equation is a function unless its graph is a vertical line. Find the solution. For the equation y equals 3x plus 4, where x equals -1. We take the -1, we replace it for x, and we have y equals 3 times -1 plus 4. When solving, 3 times -1 gives us -3 plus 4. -3 plus 4 gives us 1. So the solution for this equation, y equals 3x plus 4, the solution is -1, 1. The x value coming from here, already given to us, and we solved for the y value. Remember that a solution always is given as an ordered pair. This is an ordered pair. For the equation y equals 2x plus 1, where x is -3, we say y equals 2, we input the -3 for the x value, plus 1. -3 times 2 gives us -6. Finish the equation out, plus 1. Y equals -5. The solution for this equation is -3, -5, which we solved for. In the real-world example given, the equation T equals 21 minus 0.01 N models the normal low July temperature in degrees Celsius at Mount Rushmore, South Dakota. In the equation, T is the temperature at N meters above the base of the mountain. So the question asks us to find the normal low July temp at 300 meters above the base. All of this can be put into this equation. Here's our equation. T equals 21 minus 0.01 N. This value is our N value, the normal low, N meters above the base of the mountain. Taking this 300 meters, we put it in for the equation, and we get 21 minus 0.01 times 300. 21 minus, when you do this math out, you end up with 3. 21 minus 3 is 18. Therefore, the normal low July temp at 300 meters above the base of the mountain is 18 degrees Celsius. Doing the same problem over here. Find the normal July temp at 700 meters above the base. So we have T equals 21 minus 0.01, and the N value is here. T equals 21 minus 7. 21 minus 7 is 14 degrees Celsius. Graph. Notice these little stars. I'll randomly put these little stars up in our notes when I give you a hint. And down here it says, hint, make a table. If we're going to graph this, I'm going to try to figure out what values I'm going to use on my graph by putting it into a table. So if I use, and I generally like to use -2, 0, and 2. You just need 3 values because through 3 values you can make a fairly straight line. So I input -2 into this equation for the x value. And solving it out, -2 times 1/2 is 1, plus the 3 equals 4. And I input my 4 here in my y portion of my table. Same thing if I put in a 0 into that equation. Same equation, only now I've input a 0. Y equals -1/2 times 0 plus 3. Anything times 0 is 0, so 0 plus 3 equals 3. There's my y value. Y equals -1/2 times 2 now, 2 coming from here, plus 3. Same equation, only this time I put in a 2 in for x. Solving that out, -1/2 times 2 is -1. -1 plus 3 is 2. Input that value into the y column. Then I need to graph these. -2, 4 is back 2, up 4, done. On to this one. 0, which means 0 to the left or the right, stay right at the point of origin, up 3. Then I go over 2, up 2 for my third point. Then, using a ruler or a straight edge, whichever you choose to use, connect those 3 points, and there's your line. So we've now graphed this equation. The graph looks like this. Over here, if I have y equals 2x plus 1, I need to graph that. The first thing I need to do is solve for some y values. I'm going to just randomly start with -2, 0, and 2. So I'm going to start with y equals 2, input my -2 for x plus 1. So this first y value, -2 times 2 is -4, plus 1 gives me -3. So I put this -3 in here. If I'm going to put 0 into this equation, anything times 0 is 0, plus 1 is 1. So y equals 1. And if I put a a positive 2 in, same equation. I say 2 times 2 is 4, plus 1, y equals 5. Now I need to take these 3 sets of coordinate points and graph them. Remembering that all of our lines on our graph must have arrows on them. -2, -3, so I go back 2, down 3. There's my first point in quadrant 3. 0, 1, so I go over 0, up 1. And over 2, up 5. Using my straight edge, I can connect these 3 points fairly carefully or fairly closely, knowing this is a fairly rough drawn sketch. And the graphing of that function should look something like this. Excuse me. If we were to graph y equals 2, I would need to do the same thing, make a chart, and I input. But the problem with this graph is that it's going to be a specific line because we don't have any x variables to change the output, the y value. So if I put a -2 in, no matter what value I put in to this equation, y will always equal 2. So if at -2, it will still equal 2. At 0, 2, it will still equal 2. And at over 2, the y value is still 2. So this makes a horizontal line. Using our vertical line test, does it hit more than one point on that line? No. So therefore, a horizontal line is a function, and we've graphed that line. X equals 2. Input. Now this one's a little trickier. You have to kind of work backwards. I have to put my -2 value, my 0, and my 2 value here, and work backwards. If I put a -2 in, and I go down 2, my x value is going to be 2. if I put in a 0, my x value will be 2. And at 2, my x value will still be 2. And there you have a vertical line. Using the vertical line test, oops, I hit more than one point at the same time. Therefore, it fails the vertical line test, and a vertical line is not a function. We can still graph it. The graph would look like this, but it is not a function. On to this one. X equals 1. All values in my XY chart, if I put, are going to equal 1. X I could put in for a -2, a 0, and a 2. At -2, x will still equal 1. At 0, x will still equal 1. And at 2, x will still equal 1. Does it pass the vertical line test? No, it does not. The question said graph each and decide if the equation is a function. It fails the vertical line test, so no, this is not a function. Y equals -4. Using my chart, I put in, now since I'm not worried about my x values so much, I can put in -2, 0, and 2 here into the x column. And let's see, at -2, y will equal -4. At 0, y will equal -4. And at 2, y will equal -4. So the graph will look something like this. Does it pass the vertical line test? Yes, because it doesn't touch any of those at the same time. So yes, this is a function. Oops, this should say y equals 0. And what that, or sorry, x equals 0. And what that means is that at y equals -2, 0, 2. At -2, x will equal 0. At 0, it will be 0. And at +2, it will be a 0. And that line will actually be the x line. Sorry, the y line. So we end up with, it's a vertical line. It fails the vertical line test, so therefore, no, it is not a function. Any x equals is not going to be a function, as long as it's just x equals a number. Our last part. When we're working with two variables, we can use two different equations. And using our red solo cup theory of being able to move the variables around using the commutative property of addition, I start out with this equation and I need to get y by itself. So I shoot these around and I end up with y plus 3x equals -5. To get y by itself, I have to get rid of the 3x. It's an addition, so to get rid of it, I do the opposite and I say minus 3x. But whatever I do to one side of the equation, I must do to the other side of the equation. So when the math is all done, I end up with y equals -5 minus 3x. Now I can use my chart again. Inputting -2 into this equation, I end up, I put in a -2, I put in a 0, and I put in a +2. When you do the math, -5 plus 6 equals 1. That's my y value. -5 minus 3 times 0. -5 minus 0 is -5. That's my y value for 0. And my y value for 2, -5 minus 3 times 2 equals -5 minus 6 equals -11. Graphing those, I would go back 2, up 1 for this first point. I would go 0, down 5 for the second point, and over 2, down 11 for the third point. Using a straight edge and connecting those, this is what my graph would look like. So we solved for y, came up with some y values by solving for y, turning it into a y equals equation, and then we graphed it by using our table. So over here, if I'm going to do that, I'm going to rearrange it so that I have y plus 2x equals 3. I need to get rid of the 2x, so I subtract it from both sides. And I end up with y equals 3 minus 2x. Inputting some values, negative 2, 0, 2. If I put negative 2 into this equation, I end up with y equals 3 plus 4, because negative 2 and negative 2 multiplied together is plus 4, and therefore y equals 7 for the value of negative x equals negative 2. If I was to put in a 0, I would have y equals 3 minus 0 equals 3. And the y output for the value of x equals 0, the y output would be 3. If I put in a 2, I would have y equals 3 minus 4 equals negative 1. Now I've ran out of room here, so let's use our little eraser. And quickly erase these and give us some room to graph. Back to up 7. It's going to be right about here. Over 0, up 3. Over 2, down 1. Using my straight edge, oops, I'll connect them. And my function will look like this. Again, we needed to solve for y, which we did. We put it into a y equals equation. Then graph it, which we did by filling in the table using that y equals.